Welcome back. Today we're going to continue our conversation on solving radical equations and equations with rational exponents. Before we dive into our new material, I do want to take just a moment to review what we did in our last video. Okay, so remember when we're just dealing with basic square roots or cube roots, the goal is to isolate that term. So what that means is for this first one right here, I want to divide both sides of the equation by 2. Okay, I need to isolate that square root term. Now that it's isolated, now to undo a square root, I need to square both sides. Squaring will undo the square root, and then 2 squared we know is just the number 4. Well, now we just have to finish solving from there. Okay, I have something linear, so I know I can subtract 1 from both sides. And to divide by 3, divide by 3. I got my answer, the x equals 1. On the flip side of that, so I still need to divide both sides by 2. I need to get this term all by itself. But now I need to turn it into a radical, okay? My goal here is write this as a radical. So remember, the bottom becomes your root. So the bottom creates a cube root. And then the 4 is a 4th power, is the exponent. So now, to get rid of that exponent of 4, now I take the 4th root of both sides. Taking the 4th root of both sides will get rid of that exponent. The 4th root of 16, well, you can use your powers chart to see that that's 2, but remember, you're taking an even root. So it's really going to be plus or minus 2. Well, now I have to get rid of the cube root. So to get rid of the cube root, now I take both sides to the 3rd power. That undoes the cube root and gives me plus or minus 8 over there. Now I'm going to need a little bit more space. So I'm going to put my answer up here. But now when I go to subtract 1 from both sides, negative 8 minus 1 is a negative 9, or positive 8 minus 1 gives me a 7. And those are going to be my 2 solutions to this problem. So don't forget that's our technique for taking care of these rational exponents. Well, when we're dealing with radicals, another situation can arise, okay? What happens when you have the variable both inside and outside of the radical? Well, what ends up happening is we get something that's slightly more complicated. So look here. When I try to get rid of this radical, when I square both sides, it undoes the square root, just like it should. But then notice, that side gets more complicated. Remember, when you have something squared like that, you're really dealing with something like this, which means you need to FOIL. Okay, so when you have it both inside and outside, oftentimes you're going to end up with a foiling situation. So we got x squared plus 10x plus 25 once we fully FOIL that out. And now we have a quadratic. So think about how we solved quadratics. That was way back in chapter 4. But remember, when we have quadratics, our goal is to get a set equal to 0. Every higher level polynomial, anything besides linear, the goal is to get it set equal to 0 so we can finish solving. So I'm going to subtract that x off, leaving me with 9x. And I'm going to subtract that 7, leaving me with 18. So remember, that's the goal for quadratics, to get everything to one side, and now what you have left should be able to be FOILed. Or sorry, not FOILed, factored. So when I look at this, 3 and 6 multiply to 18 while adding to 9. So what that's telling me is I have 2 solutions of negative 3 and negative 6. However, we need to be careful, okay? Because we can't let a radical equal a negative number. Okay, that's something we talked about way back in Expo. A radical will never be able to equal a negative number. So I want you to picture plugging in -3 for that x. -3 plus 5, that's going to be 2. So the outside of that radical is going to be just fine. However, I want you to picture the same thing with the -6. If I plug a -6 in there, the outside of that radical is going to equal -1. Okay, and a radical, you can never have a radical set equal to a negative number. Just like you can never have an absolute value set equal to a negative number. Okay, so when you go and you check your answers, when there's two of them, oftentimes one of them is not going to be a real answer. It's going to be something called an extraneous solution. All right, so let's try this process again. So in this next one, I'm going to have to subtract that 3 off. Remember, I always have to isolate my square root term. So I get x minus 3. Once the square root term is isolated, now I'm going to square both sides. So that's going to give me 5x minus 1 over here. Squaring just undoes the square root. And now this is something that if I write out the squared, is something that's going to end up foiling. So that gives me x squared minus 6x plus 9. Remember with quadratics, the way we solve quadratics, or really any polynomial, is we're going to want to get it set equal to 0. So I'm going to subtract the 5x, and I'm going to add the 1 over. When I do that, now I can factor it. So what are my two solutions here? Well, I get x equals 1 and x equals 10. When you get these two solutions, remember you need to be hesitant. You need to check to see, do they actually work? Are they actually both solutions? So I'm going to come back here, okay? So at this step, I had my radicals set equal to x minus 3. Okay, that's going to be the important step I need to go and check because I can't let my radical be set equal to a negative number. So when I plug 10 in for x, 10 minus 3 is a 7. Okay, so the outside of the radical is just fine. It'll play out just like we need it to. However, if I try plugging in 1 minus 3 is a -2, and that is what is not allowed. My radical can never equal a negative number. It's not possible. Again, just like for absolute values, it's not possible. So I'm going to scratch that off and deem that as an extraneous solution. It doesn't solve the original problem that I had. So that's kind of the big idea of what we're doing today. Whenever you have the situation, make sure you're aware of foiling. Then when you ultimately get a quadratic, you're going to have to move everything to one side, factor it, and then check your solutions. All right, so a function for the distance in meters at which a car needs to stop is given by d equals 2 square root of v, where v in meters per second is the speed of the car before braking. What is the speed of the car before braking if 8 meters distance is needed to stop the car? So 8 is going to be my distance. All right, so I plug in the 8 for my distance, and now I'm solving for the velocity. Well, we need to get the absolute, or not absolute value, get the radical by itself. So let's divide both sides by 2. Let's square both sides. So I'm getting my v is 16, and in this case, meters per second. All right, that's how fast the car would be going in order to need 8 meters of stopping distance. All right, so let's get to the summary. So what I need you to do, this time I want you specifically to summarize the process of having the variable inside and outside the radical. Okay, I want you to explain that to me because it's something I didn't actually write out in these notes, but I talked you through it twice. So I want you to reiterate that process to me, how to solve having the variable inside and outside of the radical. That's going to be one of the things we talk about tomorrow at the beginning of class, and one of the things we're going to check as I'm coming around for your notes. So please make sure to have everything written down, do the summary, and then come back tomorrow ready to do your practice work.